Same kind of guy. Let's talk about the solubility, acidity, salt formation, and pKa. We have a structure here. This is a drug, and say that these drugs, they are acidic. This is an acidic drug because it can lose this hydrogen atom in the solution. Nitrogen atom here and the oxygen atom, they are not nucleophilic enough to break the hydrogen bonds of the water molecules. So the drug is water insoluble, but is a lipid soluble. So to make these drugs to be water soluble, they are reacted with strong bases. So in presence of a strong base, an example can be sodium hydroxide. So mean that we can form this. We can form this. So in place of a strong base, this one becomes a stronger nucleophile. Here I have R5 and R5. And this nucleophile is stabilized by resonance. Can have resonance structures. Now, this one is strong enough to break the hydrogen bonds of the water molecules. So it is water soluble, but it is stabilized by resonance. So we shall have this. Here, this nucleophile can form a bond here. Now, this one becomes the nucleophile. Here we have R5 and R5 prime. Here. At the same time, this can be like this. It can form a bond here. Bond can be formed with this carbon atom. Now, this one becomes the O minus. Here we have, remember this can be oxygen or it can be sulfur. Here we have this R5 prime and R5. So that's the resonance. So now the salts, this is a salt. So the drugs, they are made as salts or strong acids. Either can be oral, in oral or parental. They are made as salts to be soluble enough such that they can dissolve and penetrate the membranes. They retain the adipophilicity for crossing the membrane, but solubility is increased. The water solubility is increased. Now, about the acidity, we say that here, this nitrogen and also this one, if this one is a hydrogen, they are responsible for the acidity of the drugs. And in case the N1 or N3 is alkylated, this one reduces the acidity, but it increases the hypophilicity. So it will decrease the duration of action. About the pKa, for the substituted drugs, we have the substituted here at N3. We have the unsubstituted and the substituted. For unsubstituted means that here it is a hydrogen atom. Here means that this drug will be more acidic than the substituted one. So the pKa for the unsubstituted one is around 7.6. But for the substituted one, pKa will increase. It's around 8.4. You can see that the pKa increases for the substituted one because of decrease in the acidity. So because of this, because that these drugs, they are weak acids, because they are weak acids, the elimination in urine can be altered. Elimination can be altered by change in pH. Let's use this here. In case of the pH greater than pKa, what do you expect? If the pH is greater than pKa, for example, if the pKa of a drug is 7.6, a pH greater than this can lead to ionization. Means that we shall have this. So more of the drug will ionize and less will be unionized. Less will be unionized. Means that this one there's increased ionization. So there's reduced reabsorption in the nephron. So mean that there's increased elimination for the drug. Now, in case the pKa is less than the pH is less than the pKa, in case pH is less than the pKa. For example, if your drug is at 7.6 as its pKa, means that below 7.6, much of the drug will be unionized. So we shall have much of the drug unionized and less will be ionized. I say less will be ionized, much will be unionized. So this one increases reabsorption and decrease in elimination. So the duration of action will be increased of that drug because it is still in the body. So that's how we can alter the pH for the activity of the drugs. Let's talk about the incompatibilities. Now, since these drugs are acidic, they are acidic, means that in addition of a solution or any substance with an acidic pH, will lead to precipitation of the drug. This drug will be more unionized because of the acidic environment. So there's formation and precipitation of water insoluble dye substituted barbituric acid. Of course, they are barbituric acid derivatives. They are disubstituted. So more of the drug will be precipitated. Precipitate will form and the drug will be precipitated. Now, let's talk about the inactivation processes also. For inactivation processes, mainly, there are three. You can have redistribution. That's one. And this one, mainly for the highly lipid soluble. This one is mainly for the ultra short acting. These drugs, they can easily enter the CNS, but they can easily move out of the CNS to other tissues or other lipophilic tissues, such as the fats, the liver, and other sites. So mainly, that's the inactivation of the ultra short acting. Then we can also have metabolism. Metabolism by CYP450 enzymes. This one is for the intermediate lipophilic drugs. For the intermediate ones. So those intermediate acting drugs, they are highly metabolized. They can go to the liver and metabolized. Then some drugs can be eliminated and changed. The long-acting ones, they can be eliminated and changed because of the low solubility. The low lipid solubility means that more of the drug can be present as a water soluble and can go to the urine directly. Also remember that these drugs, they induce their own metabolism. Let's talk about the uses and adverse drug reactions of these drugs.